Hi dear student, welcome to the classes. In this session I will go for the discussion of D block element, and already I completed D block element chapter. D block element chapter, the previous year Neet and k-cet questions, what there appeared, that question I will discuss today's session. Okay, one thing, due to my congested in my board, board is very small, I think everyone seen that. Okay, and that's why in the pen and paper I plan to solve and give the trick here only. If in my board means I will write one question and drop it, it will take more time. Okay, within 15 or 20 minutes I will complete all previous year questions with this D block element chapter. This chapter carries, if every year you observe this chapter, every year 2 questions on this D block element, fixed question, D block element only. Then next, except F block element, again one question will comes. Therefore D block element, the total every year there will be 2 questions comes, dear student. That's why you observe and you learn this D block element very perfectly. Okay. Okay, we go for the questions. So we are going to solve the questions one by one. First one, which of the following is an amphoteric oxide? You see here, dear student, I discussed this one in your class only. Amphoteric oxides, acidic oxides, basic oxides. I discussed that the elements with a lower oxidation number, the elements with a low oxidation number, they are act as a acid. Then elements with a higher oxidation number, the element with the higher oxidation number, the elements with the higher, the element with higher oxidation number, they act as a base. In the between they are called as what? Amphoteric. What I discussed this one. Yes, sir. Therefore the same question this is asked, and I given in my video class also. This vanadium, whenever you see this one, vanadium pentoxide comes, this is what amphoteric oxides. But you see amphoteric oxide V2O5 here also come, but among them this chromium oxide and Cr2O3. You see chromium exists in 3 forms. Chromium, I will write here, the chromium oxides and chromium Cr2O3, and next one Cr3. You see here in this, you see here, dear student, this is what chromium oxides, chromium Cr2O3 and Cr03. You see here, this is oxidation number +2, +3, and this is +6. This lower oxidation number act as acid and higher oxidation number act as a base, but in between that is called as what? Amphoteric. What I discussed, this is in your video class only. The same, this is what CrO, lower oxidation number, this is what middle there will come Cr2O3, therefore these two are act as amphoteric. This is what correct answer, dear student. This question is your 2018, I think so. Okay. Similarly, go for the next question. So solving this one, the electron configuration of a transition element is X. Very simplest question, dear student. The electron configuration of transition element is X with +3 oxidation number. +3, they are given oxidation state, and their electron configuration they are given argon 3d5. Argon 3d5. What is its atomic number? Very simple, dear student. +3 oxidation means they are removed 3 electron. Yes, right. They are asking +3 oxidation number state of what is the atomic number of that element they are asking. You see argon means 18. This d5 means there will be 5 electrons are there, and they removed 3 electron. If they removed 3 electron, this is +3 oxidation means they are removed, right? Therefore 18, 21, you see here 18, this is what 18 plus 8, 26. Therefore the atomic number of that element will be 26 there. This is what dear student. Go for this one. We will go for the converse. Okay. You see 26th element. 26th element will be iron. Iron Fe3 state. Okay, Fe3 state. What is the first iron electron configuration? Argon 4s2 3d5. So 4s2 3d6. This is what electron configuration. If you remove 3 electron, therefore argon, next remove these 2 and one more electron from this one, this is what 3d5. This is what Fe3 state. Therefore this is the electron configuration, dear student. They are asking, this is X3 plus. They are not given the name. Okay, very simple, right? That's why I am telling you to practice this electron configuration. Okay. Next one. Next question also, it's very easy. The K-menophore act as an oxidizing agent. Okay, we know that the K-menophore is one of the good oxidizing agent in alkaline medium. When alkaline K-menophore is treated with Ki, the alkaline K-menophore treated with Ki, iodine ion is oxidized too. You very simple, dear student. I discussed this one. Whenever 2I minus ion get ionized, you see here the 2I minus ion going to oxidize to I2. This is what in presence of K-menophore. I discussed the oxidizing agent property of this K-menophore. Therefore, this one Ki converted into I2 iodine ion. This is what question they are asked. The question, dear student, very simplest, right? Very simple questions they are asked. This one also. The next question we go for that. The magnetic nature of an element. The magnetic nature of an element. I think there is some disturbance that. Okay. The magnetic nature of elements depends on the presence of unpaired electrons. Identify the configuration of transition element which shows the magnetic moment. That very important, student. The magnetic nature of element depends on the presence of unpaired electron. Okay, how we are agree for this magnetic moment depends upon unpaired electron. This is correct statement. The identify the configuration transition element which shows the highest magnetic moment. Very important, dear student. We observe that the magnetic moment formula, magnetic moment equal to square root of, don't confuse the formula n into n plus 2. If highest magnetic moment ಇರಬೇಕಂದ್ರೆ number of unpaired electrons ಏನಾಗಿರಬೇಕು? Therefore the magnetic moment directly proportional to n. ಈ unpaired electron, this is what unpaired electron. ಈ unpaired electrons ಗಳು ಜಾಸ್ತಿ ಇದ್ರೆ ಅದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್ ಏನಾಗಿರ್ತೈತಿ? ಜಾಸ್ತಿ ಆಗಿರ್ತದೆ. ಹೌದಾ? therefore ನಮಗೆ ಇವು electron configuration ಅದಾವು. ಇವು 4 electron configuration. Among them which is having highest unpaired electron we have to calculate. Here you see here D2 means there will be 2 unpaired electron. Okay, how to calculate that one also some of the students are confusing. Go for that. There are 5 tables, there are 5 d orbital, 2 electrons are filled, they are unpaired, therefore 2 unpaired electron. Next go for this 6 electron means first fill singly, then pair up. How many unpaired electron, dear student? Here 4. This is what 4 unpaired electron here. Next go for d5. D5 means there will be 5 unpaired electron, 1 1 1 1 1 5 filling, therefore all 5 are unpaired electron. Go for this one d7. D7 means you go for this one first electron filling singly, then 7 electron means there will be pairing up, therefore there are 3 unpaired electron. You see this is a 3 unpaired. You see among them here 3 unpaired electron, here 5 unpaired electron, 4 unpaired electron, 2 unpaired electron. Here number of unpaired electron is more, therefore they are showing the highest magnetic moment. Therefore we know that formula mu equal to square root of n into n plus 2. If magnetic moment directly proportional to unpaired electron, where the number of unpaired electron more, there will be more magnetic moment, dear student. This very shortcut, very high trick, dear student. Don't go for the calculation of calculate the n into n plus 2. There don't go for that. Okay, go for direct. Okay, I will solve the next questions. Okay, the transition, you see this is question also very tricky and very easy also. The bivalent element, the bivalent metal ion having the maximum paramagnetic behavior among the first transition series of the element. What they are asking, they are given bivalent. Bivalence means all are having +2 oxidation state. Okay, this is what I think so. They are given +2 only. Okay, +2. I think it is not visible. Okay, the bivalent metal ion having the maximum paramagnetic behavior among the first transition element is. ಈ ಎಲ್ಲೋ ಬೈವೆಲೆಂಟ್ ಸ್ಟೇಟ್ನಾಗ ಅದಾವು. ಇದರೊಳಗೆ ಯಾವುದು ಹೈಯೆಸ್ಟ್ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ನೇಚರ್? ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ನೇಚರ್ ಅಂದ್ರೆ ಓನ್ಲಿ ಒನ್ ಥಿಂಗ್, ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್ ಎಷ್ಟೈತಿ, ಯಾವುದ್ರೊಳಗೆ ಹೈಯೆಸ್ಟ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್ ಐತಿ ಅಂತ ಕ್ವಶನ್ ಕೇಳ್ಯಾರ ಅವರು. ಇಂಡೈರೆಕ್ಟ್ ಆಗಿ ದೇರ್ ಆಸ್ ದಿ ಕ್ವಶನ್. Read the electron configuration. Very simple. This is Mn2 plus means the electron configuration is 3d5. I will write only outermost electron configuration. Argon 3d5. Okay, argon 3d5. This copper 2 plus means, okay, they are given copper 2 plus and copper 1. Don't confuse. Copper 2 plus means what? And this one is argon 3d10. Argon 3d10. This scandium 2 plus means first element only, there is no any unpaired electron. Argon 3d 0. Scandium first element, outermost okay, go for first one electron, argon 3d 1. Copper 1 plus means, copper 1 means argon, you see 1 minute I will tell you. Copper plus 1 means this is what 3d 10. But this copper 2 plus means the electron configuration will be, we remove 2 electron, okay, 3d 10. Copper 1 means first one, if you are confusing like this, you go for the electron configuration. Copper 2 plus electron configuration will be you see here, copper 2 plus electron configuration. First copper, we know that copper is argon 4s2 3d 4s1 3d 10, 4s1 3d 10. If copper 2 plus means remove 2 electron, 1 electron from here, 1 electron from here, therefore argon 3d 9, dear student. Therefore this is what argon 3d 9. And this copper 1 is same, 1 electron we removed means this used as to argon 3d 10. This is what copper plus 1 electron configuration. Yes, right? Okay, among them which is having highest paramagnetic nature, they are asking question like this. Find the first unpaired electron, number of unpaired electron. Here number of unpaired electron will be 5. Here number of electron 9, 3d 9. 3d 9 means first filling the electrons like this only. First you see here 1 electron, 2, 3, 4, 5. Next pairing up. They are pairing up, only 1 unpaired electron here. Here 3d 1 means there will be 1 unpaired electron. There is no 0 unpaired electron. Therefore it shows it has 5 unpaired electron. Therefore it has highest paramagnetic nature. Highest paramagnetic nature, because we know that mu is equal to square root of n into n plus 2. Number of unpaired electron is directly proportional to paramagnetic nature. Okay, it is very simple right now. Next one, go for the next question. Mn2 plus compounds are more stable than Fe2 plus compound towards the oxidation state, towards the oxidation to their plus 3 oxidation, because it's very simplest question I discussed in our oxidation number concept. What is that oxidation number concept? You see here. What they are asking, this is converted Mn2 plus converted into Mn3 plus, Fe2 plus converted into Fe3 plus. Once again read the question. Mn2 plus compounds are more stable. Mn2 plus compounds are more stable than Fe2 plus. Okay, I agree for this. Mn2 plus compounds are more stable than Fe2 plus compound towards the oxidation of their plus 3 oxidation state. ಅವ್ರು ಏನು ಕ್ವಶನ್ ಕೇಳ್ತಿದ್ದಾರೆ, ಪ್ಲಸ್ 2 ಸ್ಟೇಟ್ ನಿಂತರ ಪ್ಲಸ್ 3 ಸ್ಟೇಟ್ ಆಯ್ತಂದ್ರೆ ಯಾವ ಸ್ಟೇಬಲ್, ಅವಾಗ ಅದಕ್ಕೆ ಸ್ಟೇಬಲ್ ಆಗ್ತದೆ ಅಂತ ಕೇಳ್ಯಾರವರು. ಈಗ ನಾವು ಏನು ಇದಕ್ಕೆ ಆನ್ಸರ್ ಮಾಡಬೇಕು ಅಂತಂದರೆ, ಈಗ ನೋಡ್ರಿ Mn2 plus, what is the electronic configuration of Mn2 plus? You will write here Mn2 plus. Yes, right. Mn2 plus electron configuration is argon 3d 5. ಈಗ ಇದನ್ನ ಪ್ಲಸ್ 3 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಏನಾಗುತ್ತೆ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್? ಆರ್ಗನ್ 3d 4. You see here, this is completely half filled. Yes, right. It is half filled orbital means it is more stable. If more stable ಇದೆ ಅಂತಂದ್ರೆ ಇದರೊಳಗಿನ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ತೆಗಿಬೇಕಂದ್ರೆ it is very difficult, right? It's very difficult. Okay, it is one case. Second case we go for this Fe2 plus. What is the electron configuration of Fe2 plus? Argon 3d 6, dear student. It converted into Fe3 plus means it gives electrons very easily, because one unpaired electron is there and it is not completely half filled and it is somewhat less stable. It gives one electron, it forms the electron configuration of argon 3d 5. Therefore it is more stable. Therefore for this sake only Mn2 plus electron configuration is more stable. Fe2 plus electron configuration is less stable. Therefore due to this oxidation state and electrical configuration, it shows that this Mn2 plus converted to Mn3 plus, it is very difficult. But conversion of Fe2 plus to Fe3 plus is very easy. ಡಿಫಿಕಲ್ಟ್. ಇದು ಹೆಂಗಂದ್ರೆ ಇದು ಹೆಂಗೆ ಹೇಳ್ಬೇಕಂದ್ರೆ ನಿಮ್ಗೆ ಇದು ಭಾಳ ಅನ್ಸ್ಟೇಬಲ್ ಇರ್ತೈತಿ, ಸ್ಟೇಬಲ್ ಕಡೆ ಹೋಗ್ತೈತಿ. ಇದು ಸ್ಟೇಬಲ್ ಇದ್ದಿದ್ದು ಅನ್ಸ್ಟೇಬಲ್ ಕಡೆ ಹೋಗ್ಬೇಕಾಗಿರ್ತದೆ, ಗೊತ್ತಾಯ್ತಾ? ಓಕೆ, therefore go for the option Mn2 plus is more stable with high third ionization energy. Yes, correct, exactly. This is what next go for this. Mn2 plus is bigger size. Mn2 plus has capability to fill the d orbital. No, Mn2 plus does not exist. Therefore this is the correct answer, dear student. Mn2 plus more stable with the high third ionization energy. This is what third ionization energy, removal of third electron, right? Mn2 plus to Mn3 plus plus first ಗೆ Mn to Mn plus ಆಗಿರ್ತೈತಿ, Mn plus ನಿಂತರ Mn2 plus ಆಗಿರ್ತೈತಿ, Mn2 plus to Mn3. First ionization energy, second ionization energy, this is third ionization energy. Therefore third ionization energy of Mn2 plus to Mn3 plus is very high. Okay, go for the next one. What they are asking the question, the spin only magnetic moment of nickel 2 plus. These type of questions are very important, dear student. They are asking the magnetic moment calculation, and most of the students are very confusing the formula. Magnetic moment formula is square root of n into n plus 2, not n plus 1. The unit is Bohr magneton. Okay, don't confuse the formula. I observe most of the students. Okay, first they are asking nickel 2 plus. Nickel 2 plus calculate the spin only magnetic moment. Nickel 2 plus means what is the electronic configuration? Simplest, that's why I am telling you, write the electronic configuration, perfect that. Nickel means what is the atomic number of this nickel? Cobalt, nickel, copper, zinc. Therefore this is 27th. Yes, right, nickel, copper, zinc. Okay, 20, not 27. Scandium, titanium, vanadium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, 27. Nickel 27. What this electronic configuration will be? Argon 3d7 4s2. This is nickel. If nickel 2 plus means what? Nickel 2 plus electronic configuration means what? Removal of 2 electron. Therefore it forms argon 3d7, dear student. How many number of unpaired electron? Calculate this one. The number of unpaired electron. If you are confusing like this, you go for this. This is best way. 5 orbitals are there in D. Fill the first single electrons. Next pair of electron. How many number of unpaired? 3 unpaired electron. And substitute in this square root of n into n formula. Mu equal to square root of n into n plus 2 and square root of 3 into 3 plus 2, square root of 3 into 5. Therefore square root of 15. This is what our answer, root 15 Bohr magneton. Root 15 Bohr magneton, dear student. Go for the next question, solving the next questions. Okay, you see all these questions, all your previous year question only. They are asked this type of questions only. Spin only magnetic. The present their trend, they are asking like this problematic question only. Okay, which one of the following is has the magnetic moment is 1.75 Bohr magneton. 1.75 Bohr magneton is the oxidation number S2. Okay, here one thing I will give you. Wait. You see here, dear student, one formula, you know this one, magnetic moment calculation formula. This is what square root of mu into square root of n into n plus 2 Bohr magnetic is the unit. If number of unpaired electron 1, the value substitute 1 into 1 plus 2 3. Therefore 1 into 3 square root together 1.73 Bohr magneton. If number of unpaired electron idre Bohr magneton value is to 1.73. Number n is equal to 2 unpaired electron idre 2.82. 3 unpaired electron idre 3.87. 4 idre 4.89. 5 idre 5.91. Very simple. 1 idre iವೆಲ್ಲ 1, 2 idre 2, 3 idre 3, 4 idre 4, 5 idre 5. Next the value will be nearly. It is nearly 2. Otherwise go for like this. This one 2 means it's nearly equal to 3. 3 means nearly equal to 4. 4 means nearly equal to 5. This 5 means nearly equal to 6. if magnetic moment value number of unpaired electron twice it is. ಇಲ್ಲಿ 1 ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇದ್ರೆ 2 ಇರ್ತದೆ, 2 ಇದ್ರೆ 3 ಇರ್ತದೆ, 3 ಇದ್ರೆ 4, 4 ಇದ್ರೆ 5, 5 ಇದ್ರೆ 6. Why I am telling this one? They are asking question like this. What is that? Which one of the following the magnetic moment is 1.73? 1.73 ಬೋರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅನ್ನೋದಂದ್ರೆ ನಂಬರ್ ಆಫ್ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ n ಈಕ್ವಲ್ ಟು ಎಷ್ಟು ಇರ್ತಾವ ಅಂದಂಗೆ ಐತಿ ಇಲ್ಲಿ 1. n ಈಸ್ 1 ಅಂತಂದ್ರೆ ಯಾವ ಎಲಿಮೆಂಟ್ದೊಳಗೆ ನಮ್ಗೆ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ 1 ಐತಿ ಅಂತ ನಾವು ಸರ್ಚ್ ಮಾಡ್ಬೇಕು. ಈಗ titanium 3+. What is the electronic configuration of this one? The electronic configuration will be argon, titanium, scandium, titanium. The next element only means it is 3d1, titanium +1. Next vanadium 3+. They are asking vanadium 3+ means this is scandium, vanadium. This is 3d2. Practice this, you will get the electron configuration how to write. Chromium 3 means argon 3d4. Fe3+, argon 3d5. This is what electron configuration. Calculate number of unpaired electron. How many number of unpaired electrons in each element? There will be 1 unpaired electron. Here there will be 2. Here there will be 4. Here there will be 5 unpaired electron. Here only 1 unpaired electron, therefore n equal to 1, the Bohr magneton value. You see from this one, n equal to 1 means the Bohr magneton 1.73 Bohr magneton. This is what shortcut helpful. At least you have to remember these 5 value. 1 means 1.73, 2 means 2.83. Their value will be very near, right? Easy to remember. Next one. The spin only magnetic moment of Fe2+ ion in Bohr magneton is approximately, yes, they are asked right now. You go for this one, Fe2+. What is the electron configuration? Electron configuration will be argon 3d6. Yes, right. Argon 3d6 means n equal to how much? The number of unpaired electron will be 4. If you are confusing, go for like this. It is ideal method. Number of unpaired electron 1, 2, 3, 4, 5, and next one will be 6. Number of unpaired electron will be n equal to 4. If n equal to 4 means, just now I told, if n equal to 4 means it is nearly equal to 5. Therefore n is near, this one will be 5 Bohr magneton. Okay. In chromite ore, oxidation number of Fe and Cr is respectively. If you know how to calculate the oxidation number, it is better. What is the chromate ore? FeCrO4. This is our chromate ore. What is the? They are asking first for iron, then chromium. First calculate the iron. Iron means calculate first X. Chromium. Chromium means this is what they are telling. This chromium means it is will take first 0. Will take the 0 or no? It is not 0. Okay, +2 oxidation. First we go for the +2 oxidation state. In +2 oxidation state, it is +2 oxidation state. Next, this is what there 4 oxygen is there. 1 oxygen means -2 equal to 0. Therefore, we go for this is x +2 -8 equal to 0. Therefore, x equal to +6. This is what for Fe. For chromium, we will go for chromium. Chromium means first iron +2 oxidation state plus this is what X. Next again it is -8 equal to 0. Therefore X equal to +6. Wait, here one thing, something will changes here. Okay, you see here, dear student, they are asking the in a chromate ore means this is what FeCrO4. What is the oxidation number of Fe and Cr in chromate ore? They are asking. Yes, right. First one, we know that ionize this compound. It gives rise to Fe2+ plus CrO4 2-, right? It is our ionization compound. This is what oxidation number is Fe2+, the +2 oxidation number. Therefore, we get this one for Fe +2. For chromate, you calculate right now. Chromate means it is +x plus 4 into -2 equal to -2. therefore x minus 8 equal to minus 2, therefore x equal to plus 6, therefore chromium is plus 6 and Fe is plus 2, therefore plus 2 plus 6, plus 2 plus 6. Very simple. How you see, this is what tricky. In examination also the mind will be like this, sometimes fluctuates. Okay, the spin only magnetic moment for Mn4 plus ion nearly Mn4 plus they are asking. First you go Mn means the electron configuration argon 3d 5 4s2, the removal of 4 electron Mn4 plus, yes, right. Therefore argon, remove these 2 electron, next remove this one 3d 3, the number of unpaired electron n equal to 3. If n equal to 3 means the magnetic moment is nearly equal to 4. This is what nearly equal to 4. This is what 4 Bohr magneton. This is what they are asking previous year question, dear student. Okay, this is what I planned today. I completed. These are all previous year Neet CET questions they are asked. Okay, if you have any doubts, please comment me. Thank you for watching this one.